In this lesson, we'll be comparing posted code for multi-axis positioning toolpaths. After completing this lesson, you'll be able to create NC code and analyze code differences for angular rotation. Let's carry on with the file from our previous example, and let's take a minute to explore the posted code of a multi-axis positioning drilling operation. So when we select our multi-axis setup, we can see the coordinate system that we picked. Our X, Y, and Z orientation are representative of a 3-axis vertical milling center. However, when we go down to our multi-axis positioning toolpaths, even though we selected geometry to set up our Z-axis orientation, notice the coordinate system is still in the same location, however, it's just rotated. This is the way our multi-axis positioning coordinate systems are going to work. It's going to rotate the table into a position that in effect gives us the orientation that we're looking for. What I want to make sure we understand is how this translates into the code that your machine will see. So I'm going to select just a single operation, my spot 5x1, and select post process. I'm going to be looking at milling, and then I'm going to be taking a look at two different mills, a Herco and a Mazak. First, let's take a look at the Herco and post the code. Since I have code that already is a 9001 file, I'm going to just replace it. So inside of here, we're posting just the single operation. And the lines of code that I want to make sure we identify are going to be this G68.2. Now G68.2 is going to be a tilted workplane reference code. And what this means is this is the code that tells the machine what position it needs to get into. We have X, Y, and Z zero coordinate systems, which means that the X, Y, and Z position is the same. However, we have I, J, K, U, V, and W. You'll also notice the line below it is G0, then it's another G68.2, and then we have X, Y, Z positions, and then we have another I, J, K. What these values are representing is going to be a shift in the coordinate system, and the IJK values are representing a rotation. If we take a look at this from a mathematical perspective, what these rotation values for I and J are telling us is that we're rotating 45 degrees. What the second line is telling us with the K value is that we're rotating 90 degrees in another direction. If we take a look at our coordinate system shift from our tapping operation to our spot drilling operation, our Z-axis is 90 degrees off and the X-axis is 45 degrees off. Now let's take a look at posting this code using a different machine. The same exact file, the same exact code. Again, we're going to post it to 9001 and overwrite this. And I want to focus on that same bit of code. One thing you'll notice is that the code that the Mazak controller is looking for is different than the code that we saw for the Herco. When we look at the same line for 68.2, we now have an XYZ0, which we had before, but now we have an A, B, and C rotation. Instead of having our XYZ and IJK values, we now have an actual angular rotation value, in which we have A rotating 45 degrees to reorient our X coordinate system, and B rotating 90 degrees to reorient our Z coordinate system. From here, we then have an X and Y position, and then we have a Z value for the actual drilling operation. Again, if we take a look at this, we have our G82 value that controls our rotation. This is an important topic to understand because if we're outputting this code for a different machine, the code itself is going to be different. If we output both of these operations for a Mazak, and again, we're just going to go ahead and overwrite that code, we can see here that, again, the first operation has XYZ, A45, B90. The second operation has XYZ0 again, but now A is minus 45 and B is 90. So if we look at this on the screen and we take a look at the coordinate system in the center, you can see that Z is pointing the direction of the tool, and then it rotates, in this case, 90 degrees the other direction. But in reference to the original coordinate system, it's actually moving 45 degrees in the other direction. So we have A45, B90 in the first instance, and then we have A minus 45, B90 in the second instance. If we take a look at that same code for the Herco, then we would see the IJK values representative of that. In this case, the 0.707 would be negative in one case. And again, it's just a different mathematical representation of the coordinate system in the angular shift. But it is an important discussion because certain machines and certain mills will treat the code differently. Both were using the G68.2, but one was looking for the IJK values and one was looking for ABC rotation. In general, certain mills, such as Haas mills, will look at ABC coordinate system shifts, but others, like the Herco, will need that IJK reference. From here, we haven't made any changes, but let's go ahead and just save the file and move on to the next step.
Thank you for watching our channel. Please like, share and subscribe our channel, and don't forget to press on bell icon.